So today, let's look at the new documentation that we've built for deploying smart aquaculture on your own computer through OpenShift Local. If you go to smack.computate.org, that's smaq.computate.org, and click on articles. We need to promote this on our homepage, but you go to articles and you can start at one of these documents. So install OpenShift Local on your own computer. But one of the prerequisites to that is how to become a Red Hat developer and computer requirements for smart aquaculture development. And then there's deploying smart aquaculture on OpenShift Local. All these documents here are what you need to get started. If you click on one of these, we show the prerequisite articles for this. So you'd want to start here with reviewing the computer requirements for smart aquaculture development. And what's really exciting this week is that we've been able to enable Microsoft Windows 11 Pro users to use smart aquaculture, to be a smart aquaculture developer, not just Linux, which is really huge. Linux distros that are for sure supported are Red Hat Enterprise Linux 9, CentOS Stream 9, and Fedora 34 Plus. And other Linux distros may also be supported. Now, it takes a lot of resources to run Red Hat OpenShift with the whole smart aquaculture platform. You want to make sure that you have a computer that's x86 64. Architecture, what does that mean? If your computer runs Microsoft Windows, you're good. And if you're running Linux, you probably already know if your system is x86 64. Mac OS operating system is not unsupported, unfortunately, because they do their own ARM64 type architecture that's not compatible with most systems. So unfortunately, there are older Mac OS computers that may work if you have enough resources, but the new ones, I forget what they're called, M1, M2 or something, are not because they're ARM64. So hopefully you have enough memory. Actually, we want to test this more, but it might work with 32 gigabytes of RAM with the microshift preset, but that's still to be confirmed. So right now we're saying 64 gigs of RAM and 8 logical processors. 8 logical processors can do microshift, or if you have 16 CPUs, then you can do the full OpenShift console. So assuming you have a computer running Microsoft Windows 11 Pro or Linux, keep in mind that this wouldn't work on Windows Home Edition or Education Edition. It's got to be Pro because Pro enables virtualization, which this all runs as a virtual machine. OpenShift Local is a virtual machine that runs and configures its own networking, and that's a Windows 11 Pro feature. So also keep that in mind. And once you've done that, you can go ahead and install OpenShift Local on your computer. And here's an article all about it. Actually, this is dependent on becoming a Red Hat developer, which is also free. So all of this you can do for free. So becoming a Red Hat developer is creating a Red Hat account and it's basically, you might already have a GitHub account and be an open source software developer, but this is becoming a Red Hat developer, which means you get to work with enterprise open source software solutions, the same ones that are deployed at the largest banks in the world and all kinds of companies throughout the world. So it's really powerful that Red Hat lets you do this for free. So get started there at developers.redhat.com and then come back and install OpenShift local, and it is a simple download. I explain the process. So you go and download it, and Red Hat has its own documentation about installing OpenShift local, but we're also going to do a deep dive into installing OpenShift local on Microsoft Windows here, or Linux. So it's all documented. You run the OpenShift local installer on Windows and you extract the zip file to your downloads. You run this executable and then you accept the terms and install, and it's going to install all the virtualization tools, and it's going to download a bunch of container images and virtual machine images and deploy those. And then I explain the best way to configure your OpenShift local resources to run on your machine, because it might start out with very few resources and you're going to need to bump it up to deploy the whole Smart Aquaculture stack. And I explain how to calculate the number of processors you'll need and the amount of memory you'll need, and configuring the disk size. And so it's very similar instructions for Linux. It's just different ways of creating directories and extracting files and calculating the memory, because there are different commands in Windows versus Linux. But it's a similar process. And then show you how to review your configuration, set up your virtual machine, and then start it. And then explain how to log into OpenShift local graphical console. Like, here's my OpenShift local graphical console. It explains how to download the command line tools that you need, like the OC command. And there's the OC command. So that's installing OpenShift local, and then you can start deploying everything with GitOps in the next article. So all of this is free. You deploy the microservices that you need, starting with Argo CD GitOps, which will deploy all the rest of these, including HashiCorp Vault for secrets management, Apache Zookeeper for cluster management of applications, Apache Solr Search Engine for searching the site, Smart Aquaculture site, PostgreSQL relational database for storing data, and Keycloak single sign-on for configuring authentication and authorization. And there's both Microsoft Windows instructions for that and Linux instructions, so you can follow along and create a directory for your source code and clone the GitOps for Smart Aquaculture dependent microservices that we described above. And then access Argo CD, log in, and then continue to deploy the rest of the GitOps for Smart Aquaculture. And you clone the Smart Aquaculture repo, and then you apply those resources, and it's going to automatically deploy those with Argo CD. So that gets you started, and what you end up with is an actual running deployment of Smart Aquaculture. So let's take a look at what we have in our Argo CD here. If I log in, so this is what my Argo CD looks like, and it's got all of these applications, including Vault. So these are all the setup for Vault, and then Zookeeper, Solr, Postgres, and Smart Aquaculture. And if I come here, I go to workloads, pods, Smart Aquaculture, you can see my Smart Aquaculture site running here as a pod. Oh, it looks like we got some errors, but we haven't, I guess we need to work a little bit on the import process. But if we take a look at networking routes, Um, within Smart Aquaculture, then I click here on https://smartaquaculture.apps-crc.testing, and this is Smart Aquaculture running in OpenShift. It's all running as containers, and it should let me log in if I accept the risk and continue. And oh, okay, so maybe we got to do a little more work on uh, the configuring of authentication and authorization. But we have it running now, and you can do the same. The cool thing about this GitOps is when there's bugs like the one I just showed you right here, I'll make a fix for it, and then it's going to be something that will automatically deploy within your own Argo CD to fix the problems that we encounter as we develop this application over time. So it's a good development environment for smart aquaculture and building a data-driven website like this. This is good practice for building your own data-driven website, which is what computate.org is all about. It's about teaching you how to build your own data-driven website to solve the problems in the world that you want to solve through social innovation or your own ideas. You know, that's why I built all this at computate.org, is to bring these kind of services to life through our webinar, through research, like this research going on in ecological forecasting and smart villages and AI telemetry uh, and and smart aquaculture and observability and the websites that we have up and running, which includes smart aquaculture and AI telemetry. I need to add that one up here in the Mass Open Cloud. Open data policing, racial equity report cards, trailblaze hunting consultants. All these things are going on, and they all are built in a similar way, building these data-driven services in the cloud. So anyway, so check out this new documentation that's at smack.computate.org. We have it all publicly available here for free, and get started on your own computer. So you guys have some questions?
Hey, I think it's awesome, Chris. I think it's awesome. Um, I think um, we gotta think about who is the customer, the seller. How do we approach a university if a university is interested? Just own ramps for maybe universities. What we need to think about, but I think it's good. I think you have a great product here, and we just got to get them customers to sign up for it with cost, or enough cost to make a free service possible and sustainable.
Yeah. So this is all definitely provided for free. Everything you've seen is completely free. You just need the right computer with the right specs to get started. But what we're also able to do is provision OpenShift AI workbenches, like what we do in AI telemetry, um, so that you can do this completely in the cloud. It doesn't matter what computer you're on. We can all do this within OpenShift AI as workbenches, VS Code workbenches. So we have that option too. Um, and I was going to get to work sometime this week to automate that for upcoming workshops, hopefully in Raleigh, North Carolina in October. Well, depending on what we can do there, um,
Mhm.
you know, there could be workshops out there that there may be a workshop in Las Vegas in January related to smart aquaculture. So, upcoming workshops will be able to benefit this so that people can try this out, just like we did at the Red Hat Summit this year in
Mhm.
May, and just continue to evolve this smart aquaculture solution, add the data, add more data point integrations as we interact with partner organizations who have data related to smart aquaculture, where we can bring that data into the platform and start observing it and reporting on it.
Yeah. Great work. I think, this is great for AI, great for Kubernetes. This is a great product. So the VS Code is a tremendous IDE interface, and then the other features in other languages will make it very much in demand around the world. So great job. Great job.
Yeah, thanks. Okay. Let's see.